So let's talk about how we basically conquered the syntactical, structural, and semantic equivalence issues between Java and JavaScript. Let's start from the Java to JavaScript first, and then realize also at the end of the day that it's probably important too to take some of the concepts from JavaScript and make sure that we could probably do them in Java, because we are talking about bidirectional, not just one way. But let's start with the Java to JavaScript side of the equation first. For the syntactical equivalence, it's very close to what you would think in most kind of syntax translators. The ifs and while statements and so forth have reasonably good coverage and similarity between the two language environments, where there's not really much that we need to do. In some of the cases, like doing things like iterators and so forth that you do have in Java that you don't necessarily have in JavaScript, we need to do a little bit of syntactical sugar, but we can still stay with the main JavaScript structural elements, syntactical elements to work with. The structural stuff gets a little bit more interesting, because now we start talking about how do you actually structure your JavaScript. And JavaScript is an interpretive language. It's very free form. Everybody's got their own opinions about how you model your classes and do your inheritance. But we needed to pick something that was going to be very familiar to the Java guys and then give us a good foundation for translation from Java to JavaScript to start with. So what we basically did is came up with the notion of sections. If we really looked at what was going on in Java to JavaScript structurally, we wanted to come up with sections of the JavaScript that would be well defined. This is still regular JavaScript, so we're not doing anything like having to take over the runtime or anything. This is just structured JavaScript. And these sections basically call out what you want to do, very similar to like you do in Java. You want to define a class. You want to define an interface. You want to define an enum. You want to be able to describe a constructor. You want to be able to say that you've got a static initialization block. You want to describe the classes and types that you need to work with, so the equivalent of what you do for imports. You want to have your methods look similar in terms of how they're basically going to be declared and how they're going to basically define their arguments and maybe what they basically return. So to take this step, we didn't need to change anything major, but we adopted a section mentality, and that is using JavaScript and being able to describe your class and your interface in sets of sections. This gave us the ability to take something that looks like what's in Java and have it structurally look similar to what you see basically in JavaScript. So that wasn't too hard, and you do see it in other people's libraries and implementations where they do create a structured approach for saying this is a class and you inherit this particular way. We adopted one style, and we've used it uniformly to help us solve this problem. The last one's the one that's interesting, which is the semantic equivalence. And this is where we don't have syntactic sugar to help us out. We basically don't have simple structural elements to say these are one-to-one between the two languages. You're hitting the hard part, which is basically how do you say that you're doing typing in a language that's inherently or mostly completely untyped? How do you do things like packaging and access control when those constructs don't even exist in the JavaScript world? So again, we can't take over the JavaScript runtimes. We don't want to get into the browser game. What are we going to do? Well, the answer there was we want to basically annotate the JavaScript, and we want to do it in the easiest way possible. We wanted to do it in a way that would be very natural for a Java person coming over. We wanted to do it in a way that was going to be unobtrusive, so that you didn't flood your JavaScript with so many annotations in it. It would be impossible to basically read. So what we came up with is really taking a structured JavaScript comment. And if you look at the Java declaration syntax for describing something as a public class, or this is a final member, or this is a method that's going to return a particular type and throws a particular exception. And we actually took literally the Java syntax for describing a class, describing a member, describing a method and what it returns, and actually embedded it in a JavaScript comment. We use an angle greater than and less than. If you use the comment syntax and a greater than arrow, it's basically saying the next thing that shows up in the JavaScript is going to get this declaration. And then we kind of thought, well, that means you always got to put your declarations first, and that's not always nice. A lot of times you want to put your declarations to the side, so when you're reading your code, it reads good top to bottom. So we said, oh, why don't we just invert the angle and say, yeah, if you do a less than sign, you do your comment in a less than sign, this applies to the declaration just before it. Now we can write our JavaScript and put all our annotations to the right-hand side, and when you read your JavaScript, it looks perfectly good. But when you see the right-hand side, you can see the annotations that basically tell you, hey, this thing is a final member that's of type int. Oh, wait a minute, this is a method that's going to take an int in, returns a string, and throws an exception. So now for a JavaScript person reading it, he sees his normal JavaScript. For a Java guy reading it, he gets to see the annotation information. Now, the interesting part is what do you do with the annotation information? So taking the syntactical equivalence, taking the structural equivalence, and taking the semantic equivalence coming together give us some interesting opportunities. And without some sort of tooling to tie this together, you really miss a lot of the semantic goodness. So the next part of what we're going to talk about is how we tie into the tooling, and a little bit more about how do we take the JavaScript abilities and bring it over to Java.